Alright, in this video we will practice graphing rational functions such as these. A rational function is a function that has a polynomial for a numerator and another polynomial for the denominator. Okay, first of all, let's find the x-intercepts. If there's no number added on to the end or subtracted on the end, then what you can do is just set the numerator equal to 0 in order to find the x-intercepts. So if I have x plus 3 equals 0, subtracting 3 from both sides, that gives me x equals negative 3. That means we have an x-intercept of negative 3 comma 0. Okay. Now, as far as the y-intercept is what you get when you plug in 0 for all the x's. So if I put a 0 here, here, and here, that means these terms are all gone. So that's just going to leave 3 over negative 12, which is negative 1/4. That means the y-intercept is going to be 0 comma negative 1/4. Also, we will surely be typing this in our TI-30 XS multi-view. Alright, so I've got x plus 3 over x squared plus 4x minus 12. So that's x squared plus 4x minus 12. Okay. Now, I'm in ask mode, as you saw here. Let me go back again. See how normally your calculator will be in auto mode, and that's where you come and you can scroll around and see whatever you see. But that only gives you integers. So if I go to 0, that does give me the y-intercept. So 0 comma negative 1/4. There you go. However, I spend most of my time in ask mode. So instead of auto, I switch it over to ask. And in that case, I can type in whatever values I want. So if I wanted to know the y-intercept, I would just type in 0 and it gives it to me. Alright, that just gives me more control so I can do decimals. Okay, anyway, let's go ahead and graph these points so far. So the x-intercept of negative 3 comma 0, I'm going to go ahead and graph that point. And 0 comma negative 1/4 would be right here. So I've got those 2 points so far. Now, vertical asymptote. You will get the vertical asymptote or totes by setting the denominator equal to 0 and solving. So in this case, I've got this trinomial. So if I set this equal to 0 and solve, the way I would solve this quadratic equation is I could either use the quadratic formula or I will try to factor it first. So x squared will only be x times x. 6 is either going to be 3 times 4 or it will be 2 times 6, or it could be 1 times 12. I'll start with looking at the middle being 4. The 2 times 6 is my best option. Alright, inner plus outer equals middle. So inner I have 2x, outer I have 6x. I'm trying to get positive 4. I can get that if I have a positive 6 and a negative 2. So there's my negative 2, there's my positive 6. Also, I need to get negative 12. Negative 2 times positive 6 is negative 12, so there you go. I will get the actual zeros by setting these equal to 0. So if I set x minus 2 equals 0, that gives me x equals 2. If I set x plus 6 equal to 0, that's going to give me x equals negative 6. So these are my two vertical asymptotes, x equals 2 and x equals negative 6. Okay, I'm going to go ahead and graph those vertical asymptotes. Alright, so there you go. Next it's time for the horizontal asymptotes. There's only ever one, so horizontal asymptote. Anytime you talk about the horizontal asymptote, you have to stop and consider the degree. the degree of the numerator and the degree of the denominator. We have to figure out which one of these three situations are we in. If the degree of the numerator is less, then it's y equals 0. If the degree of the numerator is equal to the denominator, you divide leading coefficients. If the degree of the numerator is greater than the denominator, then there is no horizontal asymptote. So for this problem, the degree of the top, the numerator has degree 1. The denominator has degree 2. All right, so since the degree of the numerator is less, that means y equals 0 is the asymptote. All right, that's just the x-axis, so I'm going to go ahead and graph that. All right, so there you go. Notice that I have a point sitting right on the horizontal asymptote. Okay, the x-intercept, -3, 0, is on the asymptote. Some students think that you cannot cross over the horizontal asymptote. That is false. So let me be clear. You can cross over the horizontal asymptote. The horizontal asymptote just represents the end behavior of the graph. In the middle, anything can happen. You can definitely cross over the horizontal asymptote. Okay, so I'm going to need more points to graph now. So I have 3 zones at this point. I've got this zone over here on the left, I've got this zone here in the middle, and I've got this zone over here on the right-hand side. Okay, the zones are separated by the vertical asymptote. So I need to pick at least 3 points in the yellow zone, at least 3 values in the green zone, and at least 3 points in the pink zone. All right, so that's where my head's at. Okay, so over here to the left in the formerly yellow zone, I'm going to pick values like, for example, -7 and -8. Okay, so let me write that down. So I'm going to do -7 and -8. Okay, but there's one additional point I'm going to do. Other than just doing integers, non-decimals like -7 and -8, I'm always going to pick a value that's really close to the asymptote. All right, so instead of doing -7, -8, and -9, I'm always going to pick a value like -6.5. All right, something that's close to the asymptote. So I'm going to pick that, -6.5. And in the same way, when I do the middle zone, I'm going to definitely pick a point that's really close to the asymptote on the right-hand side. So this is -5, so this would be -5.5. So I'm going to definitely use those decimals. Okay, so you see this is the asymptote right here. So I picked a couple values, but then I picked the decimals on either side. You should do the same. All right, so I've got that. So I might do -5 would be a good one to use. Okay, and I've got that point right there, but maybe -1. I'd like to know what's going on there. Okay, now as I get close to the asymptote, again, here's the asymptote at 2. I definitely want to know what's happening really close to the asymptote. So this would be 1.5. So I want to know what that is. So I'm going to check out 1.5. Now here's the asymptote right here. Okay, so I'm going to actually add values onto this. Okay, so I want to know what's going on right on the other side of this line too. So this is 2, so I'm going to do 2.5. All right, and then after that, I can do whole numbers again. So I'll do 3 and 4. Okay, I'm running out of spaces. I'll just put an extra box over here. Okay, so feel free to do what I did and add on extra numbers. So notice here's the other asymptote right here. So anytime I have an asymptote, I'm going to do the decimals on either side. You should do the same. So I'm going to get all these values right now off the calculator. And I'm going to do it using the ask feature like I showed you before. So I want to know what's happening at -7, so I just type in -7. I want -8, I'll type that in. And I wanted -6.5, so -6.5. Okay, I've got all these answers. So, okay, at -7, I'll toggle it. That's -0.4. Okay, -8. That's -0.25. All right, and at -6.5, that's -0.8. Okay, those are all really small numbers. That's really interesting. Okay, now let's look at -5.5. So let's see, -5.5. Okay, so that's -0.7. I'm sorry, that's +0.7. And at -5, okay, that's 2/7. So that's 0.3. At -1, all right, these are all such small numbers. At -1, I'm at -0.1. And at 1.5, I'm at -1.2. Okay, what about 2.5? Okay, that's 1.3. What about 3? That's 2/3. Okay, so that'll be 0.6 repeating. I'll call it 0.7. And what about 4? All right, that's a really small number. So that's about 0.4. All right, so I'm just going to plot all these points and see what I've got. All right, so here's what it looks like. I've just plotted all of those points that I just picked. And they're all really close to the x-axis, but yet I've graphed enough of them that I can get a feel for where these graphs are going as they approach the asymptotes. But notice that I have some above the x-axis here, and then I've got some below, and then this one's right on the line. So I can definitely see that it's on this side it's above, and on this side it's below. So it's going to cross through the horizontal asymptote, which is just fine. All right, so the graph is going to look something like this. Notice that even though it looks like the graph is touching the asymptotes, in your mind you just have to understand that it really is not. Alright, so now we can do the domain and range. The domain is the x values, so we are looking from left to right across the graph. Now this graph goes from left, it goes left forever and it goes to the right forever, but we have two vertical asymptotes and the graph never touches these vertical asymptotes, so they have to be left out. Alright, so I have to say the domain in three parts. So I will start with negative infinity right up to the asymptote, okay, which is at -6. So negative infinity to -6. All right, that takes me from here to there, and then now I'll do -6 to +2. So I'll do union -6 to +2, and that takes me from here to here. I've covered this part of the graph. And then I'll pick up and do 2 to infinity. All right, I'm careful to use round parentheses because the asymptotes are never touched. They cannot be included in the domain. All right, now the range is similar, but the range represents the y values of a function. So I need to look at the graph from bottom to top. Now, from bottom to top, this graph goes down forever, and it goes up forever. So I'm tempted to say negative infinity to positive infinity. I have to stop and think about the asymptote, because very often we have to leave out the asymptote. In this case, we don't have to leave out the asymptote. Because the middle part of the graph crosses right through the asymptote, we do in fact have values on this function right on the asymptote. So we don't have to skip over the asymptote when you have points there. So the range will in fact be negative infinity to positive infinity because of the middle part. If this middle part weren't here, then I would say negative infinity to 0 and then 0 to infinity. But the middle part just goes straight on through, so we won't skip the asymptote. Okay, now we need to do increasing intervals and decreasing intervals. So when we do these, we have to go from left to right across the picture. And so as we do that, some of the time we're going downhill and some of the time we're going uphill. Okay, so as I move across the graph, starting from the left, I'm going downhill for this part of the graph. Now then I got to pick up here, and I find that I'm going downhill all the way. Okay, and then I have to pick up here, and I find that I'm going downhill again. It's all downhill. Every part of this graph is a downhill. So this graph is decreasing along its entire domain. Don't forget though, we still are skipping the asymptotes. So basically the domain and the decreasing intervals are going to be the same thing. Okay, it's going to be negative infinity to -6, union -6 to 2, union 2 to infinity. All right, basically the entire domain. There are no increasing intervals, so we'll just say none. Now as far as symmetry, all right, this is trying to be odd symmetry. Odd symmetry is the one where if you turn it upside down, it still looks the same, rotational symmetry. This has rotational symmetry, but the center of this graph is about here. Okay, this is the center of the graph, is somewhere in here. So it has rotational symmetry there, but in order to be odd, it has to have rotational symmetry around the origin, which it does not. So it's because it's shifted over, then there's no symmetry. So we'll just say neither. All right, remember that even symmetry is the one where the y-axis splits it down the middle and it's mirror images. So we definitely don't have that. So we'll just say neither. And that's it for this video.